Good morning, all. Today we will learn about moment of inertia. Okay. Now, moment of inertia is nothing but it is a measure of an object's ability to resist angular acceleration. That means it is a measure of the ability of an object to resist angular acceleration. Suppose that a body has a mass m and a linear velocity v, then its kinetic energy is, as you all know, it is half mv square. Now, suppose that the body is moving with the angular velocity omega and it has a moment of inertia I, then the kinetic energy of that body will be half I omega square. Now you might have seen clay pots are made by potters. Okay, now how is it made? You can see that the wheel is very important. The design of the wheel, you can see that a very heavy mass is concentrated along the rim of the wheel, and with the help of a long stick, the potter, I mean the person who makes the pot, will bring the wheel into a very high speed. That is, the wheel will be spinning at a very high speed, and that motion, that is the high speed spinning motion, will remain, and that means that wheel will spin with a very high speed while the potter makes the pot. And why this wheel spins for such a long time? The answer is that due to the large moment of inertia of the wheel. So it is due to the large moment of inertia of the wheel that it spins for a long time. Okay. Now, linear momentum is P is equal to mv, where m is the mass and v is a linear velocity, whereas angular momentum is capital L. It is given by moment of inertia I and angular velocity omega. So we have learned about conservation of linear momentum. Linear momentum comes in the case of linear motion, and similarly in circular motion we will have conservation of angular momentum. So you might have seen dancers spinning on their toe. That is, they spin very fast when they keep their arms close to their chest, and they will spin slow when their arms are far apart. Okay, and this is because of moment of inertia. This is because moment of inertia is less when the arms are close to the chest, and hence in order to keep this angular momentum same, the angular velocity has to be increased as per the equation L equal to I omega. So the dancers who spin on their toe, they will spin very fast if they keep their arms very close to their chest, and if they keep their arms apart, their spin will be that is, their motion will get slow, and this can be explained based on the moment of inertia and the law of conservation of angular momentum. So study the reasons for that. This is given here, this paragraph. This is because moment of inertia is less when the arms are close to the chest, and in order to keep angular momentum same, what should we do? The angular velocity has to be increased as per the equation L equal to I omega. Okay, now next topic is torque. Torque is nothing but the ability of a force to rotate a rigid body about an axis. You might have seen that it is very easy to open a door by pushing it at its free end rather than closer to the fixed end. So this is because of toe. Here the door is performing rotational motion, and so in order to when the force is exerted on a rigid body pivoted about an axis, the object rotate with respect to that axis. So we can study all the definition is enough, and that is what a toe means. It is the ability of a force to rotate a rigid body about an axis, and it is a vector quantity. It is denoted by the letter tau. It is derived from the Greek letter. Its expression is tau is equal to F dot D, where F is the force applied and D is the distance from the axis of rotation. Its unit is Newton meter. So the application of tau is one of the application of tau is that the one given here, that is, it is very easy to open a door by pushing it at its free end rather than closed to a fixed end. This is because of tau. Now See, this tabular column shows some proper linear comparison between linear motion and angular motion. In linear motion we have displacement dx, whereas in angular motion we have displacement d theta. In linear motion velocity v d is equal to dx by dt, whereas in angular motion velocity is given by omega is equal to d theta by dt. That will be angular velocity. Linear motion it is linear velocity, whereas in angular motion it is angular velocity. Now linear acceleration a is equal to dv by dt, whereas angular acceleration is alpha equal to d omega by dt. This definition we have first studied in the last class. Then in linear motion you have mass m, whereas in angular motion we have moment of inertia I. Linear momentum p is equal to mv, angular momentum L equal to I omega. Then kinetic energy in case of linear motion is half mv square, whereas kinetic energy in angular motion is half I omega square. In linear motion it is half mv square. Now in linear motion we speak about force, whereas in angular motion we speak about torque. Now some of the examples for the existence of torque is that when a tire of a bus get punctured, we can see that long levers are used in order to remove the nuts instead of small ones, or instead of using small spanners we are using long levers to remove the nut. Why? Because the use of long levers increases the torque, and this will definitely make it easy for you to remove the tight nut. Same reason in the case of large and heavy vehicles have large steering when compared to small cars. Why? Because it increases tow and it will make you drive easy. Similar is the gear system in vehicles. That is also based on tow. That is, when you start a car from still position, you will have to apply more torque than that required while you are at a higher speed. So these three incidents shows the existence of tow. Next topic is centripetal acceleration. You know what acceleration is? It is nothing but rate of change of velocity. Now suppose that a car is traveling with a uniform speed along a straight line. Then its acceleration will be 0. In that case we say that that car is in uniform circular motion. So what is uniform circular motion? Or an object is said to be in uniform circular motion if it moves with a uniform speed along a straight line with a 0 acceleration. So in uniform circular motion, the linear velocity at any position will be tangential or perpendicular to the radial vector. Okay. Now from this we can define what is centripetal acceleration. That is, centripetal acceleration is nothing but acceleration associated with an object in uniform circular motion. It is directed perpendicular to the path and is always pointing towards the center of the circle. So note that definition. Centripetal acceleration is that acceleration associated with an object in uniform circular motion. It is always directed perpendicular to the path and points towards the center of the circle. And it is given by A is equal to V square by R. Here R is the radial distance. Okay. Now what is centripetal force? Centripetal force is nothing but the force associated with an object in uniform circular motion, and it acts in the same direction as that of acceleration. That is, so centripetal force is the force associated with an object in uniform circular motion and its direction is same as that of centripetal acceleration. Now you know that suppose that a car is moving along a circular road, then we say that it is in uniform circular motion, and the car maintains that uniform circular motion due to centripetal force. Now from where this car get the centripetal force? The centripetal force required for the car to remain in uniform circular motion is provided by the friction between the tire and the road surface. Okay. Now you can see that when the car is drawn at a very high speed at a sharp curves, what will happen? The car will skid or the car will skip. Why? Because if you are driving a car at a very high speed at a sharp curves, then the friction will not be strong enough to provide the necessary centripetal force to keep the car in uniform circular motion. So the car will skid away from the road in a direction tangential to the road. Okay, so similar is the thing that you might have observed in athletes who participate in discus throw. That is, before throwing, you might have seen that the athletes, they stretch their arms maximum. Why they stretch their hands at maximum? In order to increase the radial distance, and at the same time they will also spin at a very high speed. Why? In order to increase angular speed omega. So by stretching their arms, they will increase the radial distance r, and by spinning at a very high speed, they are increasing their angular speed omega. So when r and omega increases, what happens? When the ball is released or when the disc is released, the disc will go away with the maximum linear velocity v equal to r omega. That is, it will go with the maximum linear velocity and travel in a tangential direction. So here in today's session, you have to learn the centripetal force and centripetal acceleration very well, its definition, unit and all. Then what is torque, it has applications. Then the reason why the dancers spinning on their toe move fast, that particular thing, all these applications you will have to study, also the definitions and the units. Okay, so today for today this is enough. Okay, thank you.